So today we're going to talk about solving logarithmic equations. So a couple things that you want to remember is that the argument must be positive, and because of that, we have to check our answers. So any solution that would create a negative argument or an argument of zero is an extraneous solution. So we can't include that in your final answer. So let's look at some examples together. If you have a logarithm and it's set equal to another log, all you have to do is set the arguments equal to each other and solve. So in this problem, I have log base 4 and a log base 4. So I'm going to take my arguments, set them equal to each other, and this is just pretty much a linear equation. So I'm going to move that x to the right side. So I'm going to subtract, and I'm going to subtract the 17 to the other side. And then finally, I'm going to divide by 7, which gets me x is equal to -2. So I'm going to take that solution and I'm going to take it and plug it into my arguments. And I'm going to see, all right, well, does this make my argument of your log a negative or does it make it a 0? So let's take that -2 and plug it in for x. -2 plus 3 is a +1. So it's a positive answer, so I'm good. I'm going to take that -2 and plug it in for that 8x plus 17. I get a +1. So that answer of -2, it is a solution, so it works. Okay, another example is, let's say you happen to have an equation, have a single logarithm. Well, we're going to have to go ahead and then rewrite your equation in exponential form. So we can do our loop. So 4 to the second power is going to equal that argument, which is x plus 3. I know 4 squared is 16. And then I'm going to subtract 3 on both sides, which gets me x is equal to 13. I'm going to take that 13, I'm going to plug it in for x. 13 plus 3 is a positive number, positive 16. So I know that that solution is good. Here I still have a single log, so what I want to do is, again, I'm going to isolate that log. It's a natural log. So what I want to do first is subtract 1 from both sides. Then what you have to remember is your natural log has a base of e. So if my base of e, I'm going to do that loop and I'm going to rewrite in exponential form, which gets me e squared is equal to x. When I plug in e to the second power in my calculator, I get 7.389. When I take that number and I plug it into that argument in for x, yes, I still get that same positive answer. So that solution checks out. Here I have a single log, so I got to rewrite an exponential form, but I got to get rid of that 2, and I got to get rid of that -4. So let's add 4 to both sides first. Then this is 2 times the log. That's a coefficient, so I'm going to divide both sides by 2. Now what I have is I've got a base of 2 to the 5th power is equal to x, which gets me 32. Take that 32, plug it back into my argument. Is it a positive argument? Yes, it is. It's 32. So I am good. Now, there will be some times where you might have to use your properties of logarithms to condense before we solve. So if you need a little refresher on the properties of logarithms, you can check the other video and refresh about those properties. Now, on the left-hand side, what you see is you've got 2 different logs. So you'll have to think back to, okay, well, what property dealt with 2 logs that were separated with a subtraction sign? That was actually the quotient property. So my bases are the same, log base 5, log base 5. So what I'm really doing is I'm kind of working backwards, right? I want to condense. I want to take that x, take that 7 in my argument, and I'm going to put it in a fraction. So log base 5 of x over 7. Notice that now you have a question pretty similar to the very first example. When I've got a log on both sides, well, I can set my arguments equal to each other and then solve. I can multiply both sides by 7, which gets me 14. So now take that answer, plug it back in. Where do you see your x? Positive answer, I'm good. So x is equal to 14. Okay, here's another example. Look on the left-hand side. You've got two logarithms that are separated by an addition. So that was actually your product property, which I take those arguments 6 times x plus 1. Notice my base, still 3 on both sides. So my arguments, I can set them equal to each other. So 6, x plus 1, and then 5x minus 3. And then this becomes your linear equation. Let's go ahead and subtract 5x from both sides. And then subtract 6, which gets me x is equal to a negative 9. Take that negative 9, plug it back in. So when I plug in that negative 9, I get negative 9 plus 1, which is a negative 8. Now with that negative 8, I see I needed to have an argument that was positive. So that negative 9 is actually an extraneous solution and does not work. And so this answer is no solution. Now in this question here, we have the natural log. So what I can do is I can condense, I can multiply those two arguments together. So what I can do is then I can distribute that 4. Let's just simplify that. Let's get that 4x minus 28. What you will notice is that it's a natural log, so I have a base of e, so I can rewrite. So e squared is equal to 4x minus 28. Let's kind of simplify that e squared to get a 7.389. I can add 28 on both sides, and then I can divide by 4 to get x by itself. I take that 8.847, I plug it back in for the x, so minus 7, I still get a positive answer, so my solution is good. So here are some things to remember. When you check your answers, make sure that your argument must be positive, so no arguments of 0, no negative numbers. Now remember your properties of logarithms, so that way you might need them to condense your logarithms before you actually take those steps to solve. So I hope this video was helpful for you and you are able to go ahead now and solve these logarithmic equations all on your own. Thanks for watching and we'll see you next time.